So this is 4.2. What we're doing is we're going to continue graphing the quadratic functions, but now we're going to go to a different form. In the previous section, we talked about things that are in standard form. So this is going to be a link to that section, and we're going to continue to graph here. So the first one is we're going to say the vertex form of a quadratic equation is in the form y equals a and then x minus h squared plus k. This minus h and plus k should be very familiar to you from when we did the absolute values. As I've been telling you all along, the a, the h, and the k, and the way we shift things is exactly the same when it comes to something that's in this form. The second one is what we call intercept form. And what you may be familiar with, if you've done this before, is we call it intercept form, but you may think of it as factored form. So these are the two different forms we're going to talk about in this section. We're going to rip through this pretty quickly as I can, because it really is the same concept throughout from the first section to this section. So I just want to make sure that I give you the information you need here. So let's start with vertex form. So first of all, when we look at this form right here, we have a times x minus h plus k. What this means is a normal y equals x squared graph starts through the origin, just like the absolute value. So what we're going to do is this part right here is going to shift it. And it's going to shift it in the opposite direction of whatever the number h is. So if it's a plus sign, it will shift it to the left. If it's a minus sign, it will shift it to the right. So what you want to notice is that the vertex is not going to be negative h comma k. It's going to be positive h comma k because the standard form already has a negative in it. Okay? So for example, in this one right here, this negative 8, because it's negative, the vertex will be a positive 8, and then it's going to go up 35, so it's going to be a positive 35 as well. So the vertex in this one would be 8 comma 35. Okay, let's look at this example right here. So we're going to graph the quadratic that's in vertex form. First, we're going to identify the constants. The 1/2 goes out front. The h is going to be the opposite of what the sign is, so it's going to be negative 1, and k is going to be exactly what you see, which is negative 2. So therefore, with the parabola opening up, because of with a being greater than 0, the a out there is positive, therefore we have a parabola that opens up. So our vertex is going to just simply be negative 1, comma, negative 2. And the axis of symmetry, we always say, is the same as the x value of the vertex, so that's negative 1. So we will plot that first. We're going to plot negative 1, comma, negative 2. So there's our vertex. And then we're going to also plot our line of symmetry. And then we're going to do the same thing, sort of the same thing we did in the last section, except now we're going to actually just pick points. So 2 points have been given to you, 1 comma 0. So we can plug 1 comma 0 in. And remember, you can get those points just by plugging in 1. If we were to take this 1 and plug it into this equation up here, we would get y equals 0. And if we plug 3 into this equation up here, we would get y equals 6. 3, 1, 2, 3, 4, 5, 6. And then we do the exact same thing we did in the last section. We do the mirror image. 3 away, 3 away. 1 away, 1 away. And then we draw our graph the best that we can. A little bit harder to do on the Mobi. You guys can probably do it a lot better when you're actually drawing it out. That's a very terrible graph, but you guys get the idea. So the other point was at 1 and 0, and then 3 and 6, and then the reflections are the ones that we plotted over here. Okay, and then we drew the parabola through. Okay, so what I want you to do is, on your own, I want you to do this problem right here. I want you to graph it. And I am going to ask you a couple questions on Edpuzzle. I'm not going to, of course, have you graph it on the computer, but I'm just going to ask you something about specific points. So go ahead and try that. So when you graph this, the main thing here is making sure that you found your vertex at negative 1, comma 3. I plugged in a value to the right, got the mirror image of it, and I just drew my parabola. I really only need to see 1 point on each side, and then you can draw the general shape of the graph. But I do need to see a point on each side, and you kind of showing how you got that. So the point on the right there would be by plugging in 0. So that was 0 plus 1 squared plus 3. So we get 1 plus 3 is 4, so 0, comma 4 was our other point, and then we found the reflection of that. Okay, so let's move on to the next page. Okay, the next page we're going to talk about intercept form. So intercept form is what we also know it as is factored form. So it's in the form where if we were to factor a function and do x minus or x plus something, x minus x plus something, that's what gets us to factored form. So what we're going to do here is this is actually a pretty simple process. Once we have something in factored form, we can plot our x-intercepts. Something that is in factored form, that's the whole reason why we factor something in the first place, is to know where our intercepts are, our x-intercepts. So in this case, P is one of our intercepts, and Q is one of our other intercepts. And again, we have to be very careful to understand this is not negative P and not negative Q. Not negative P and negative Q. The reason is because we want to know what is the value that will make this 0. So if this value was 2, then we need a positive 2 to make this 0. 2 minus 2 equals 0. So if you see minus 2, then that means the intercept is what makes it 0. Once we have our intercepts, we can take the two values, add them up and divide by 2, and that will give us exactly what the middle point is and what the axis of symmetry is going to be on, which will help us find the intercept, which will help us find the vertex. So let's just get right into this equation right here. So we have negative 2 quantity x minus 1, x minus 5. This is intercept form. Our intercepts here, and we can call them P and Q, but they're really x and x. So P is equal to 1 because 1 minus 1 is 0. Q is equal to 5 because 5 minus 5 is equal to 0. So therefore our points are at 1 comma 0 and 5 comma 0. So we can actually plot those on our graph. 1 comma 0 and 5 comma 0. So there's our two intercepts. Then what we can do is add the two intercepts up. 1 plus 5, which is 6. 6 divided by 2 is 3. What that means is that's going to be where our axis of symmetry is. So we can just go straight to x equals 3, and we can actually draw a line knowing that our vertex is going to be somewhere on this line. So now we can plug our 3 into our original equation. So we have negative 2 times 3 minus 1 times 3 minus 5. And we evaluate this. We get negative 2 times positive 2 times negative 2 is a positive 8. So therefore our vertex is 3 comma 8. So there's our vertex. We already have our 2 points plotted. And now we can draw our parabola. Okay, and that's all there is to it. Okay, what I want you to do is I want you to do these two on your own. And again, answer the questions in Edpuzzle that are asked of you. And then when you answer those questions, you'll obviously see if you did things correctly or not. So in the first one, you want to make sure that when you label a point that a y-intercept, or sorry, an x-intercept has to have 0 as your y. So your x value is 3, y value 0. X value negative 7, y value 0. So that's what you should have gotten for that one. On the second part, again, the first thing you want to do is find your x-intercepts, which is at negative 2 and positive 4. So that was our first step. Then we find the middle point between that. So we do negative 2 plus 4 divided by 2, and that is equal to 2 over 2, which is equal to 1. So that's where the axis of symmetry is, x equals 1. We then plug the 1 into our equation to get our y value. So our vertex is 1 comma negative 9, and then we draw our graph through the 3 points that we have. So hopefully that makes sense. Okay, now moving down here, sometimes we're going to need to take something that is in intercept form and put it into standard form. This is really easy because all it takes is multiplying. And hopefully you all remember the concept of foiling. Foiling is where you have a quantity of two things like this, and what you do is you multiply the first terms by each other, x times x. You multiply the outer terms by each other, x times 3. The inner terms by each other, negative 1 times x. And the last terms by each other, 1 times 3. So what that looks like when we actually multiply it out is we leave the negative 4 on the outside until the end. x times x is x squared. X times 3 is 3x. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. And then what we do is we simplify the inside. So those middle terms are like terms. So we simplify those. So x squared plus 2x minus 3. And then our last step is to multiply the 4 through to everything. So we have negative 4x squared minus 8x plus 12. So that's how you put this into standard form. Okay, let's move on to the next page, or last page. And this is going to be the same concept. We are going to be taking something that's in standard form and putting it, something that's in vertex form and putting it into standard form. So the same thing. Now, the one mistake, you have to pay attention to this, and you have to make sure you don't make this mistake. Before I write this out, this is not x squared plus 9. You cannot bring the squared through and do that. You cannot do that. Please do not do that. That is a common mistake that a lot of students make. Instead, we have the quantity x minus 3 squared. So what we need to do is we need to put x minus 3 twice and then FOIL it. So we're going to do that very quickly. So on the inside, we'll be left with x squared minus 3x plus 9. And then we still have our plus 9 on the outside, which is equal to 2x squared minus 6x plus 9 on the outside. Now multiply your 2 through. 2x squared minus 12x plus 18 plus 9. And then simplify that. We get 2x squared minus 12x plus 27. And there's our answer. And you have another example right here that you can follow along with step by step. We did the exact same thing over here that you can follow along with. Okay, so what I would like you to do is, actually, we've already done questions like this, so we're just going to leave these. We did one on the previous page like this, so instead of you going through and doing the same problems, we will leave these. You can do them for your own practice if you want to, and then ask me in class about them. So hopefully this made sense, and I'll see you in class.